All right, in this video, we're going to go over the concepts of marginal cost and marginal revenues. And so really marginal costs and marginal revenues, they're just special cases of differentials. So if you recall earlier in class, we discussed what a differential is. Let's just kind of recap real quick. So recall that a differential is used to approximate the change in a variable. If we're given some function f of x, we said the differential of this function is given by dy is equal to you take the derivative of the function and you multiply it by dx, where dx is the change in the x values. So it turns out, here's a new part, whenever our function f of x is a cost of revenue function, and dx is specifically equal to 1, has to equal to 1, then this differential actually becomes a marginal function. Okay, so for folks that have taken accounting and things of those nature before, you know what marginal means. So for instance, a marginal cost tells us how much our cost will change if we produce one more unit. The key here is that marginal cost, marginal whatever, only tells you about the next unit because dx is equal to 1. You're only changing your x value by 1. Marginal revenue, similar definition. Marginal revenue tells us how much our revenues will change if we sell one additional unit. So let me give you some notation here. Let's do some notation. So MC of X, I'm going to let that represent marginal cost. Okay. Well, marginal cost is equal to, well, let's treat it like a differential. All right. So if we're given the cost function, we know we take the derivative of the cost function and we multiply it by dx. Well, since we're dealing with a marginal cost, dx is going to equal 1. So dx is 1. So this means that marginal cost is just c prime of x times 1, which is just c prime of x. So the marginal cost is simply just the derivative of your cost function. In that exact same vein, mr of x, okay, we're going to let this denote marginal revenue. And for the same reasons, marginal revenue is going to equal, it's going to be simply the derivative of your revenue function. Because remember, dx is 1 already. So I'll go through the whole thing. It's really r prime of x times dx, but because it's marginal, dx is going to equal 1. Therefore, this equals just r prime of x. Okay? So when you want to find a marginal cost, marginal revenue, simply take the derivative of the cost and revenue function. Okay, so let's go through several examples here. Okay, for example, we go different color here. For example, suppose we have the following cost function. Suppose c of x is equal to, let's say it's negative 1/6 x third plus a 1/2 x squared plus x plus 2. What is that? That's our cost function, right? And so what if the question asked you to calculate MC of 4? So calculate the marginal cost of 4 units and let's interpret what that value means. Okay. All right. So here we go. First step is let's calculate the marginal cost function. So for the reasons we just discussed earlier, our marginal cost function, which is a function of x, will be, let's take the derivative of our cost function. Okay, so this is just our standard derivative. So we got the negative 1/6 x to the third. We know that the 3 comes out front, multiplies a negative 1/6. So you have a negative 3/6, right? It's 3 times a negative 1/6 times x squared plus our 2 is going to come out front, multiply the 1/2. So that's going to be 2 over 2x plus the derivative of 1x is 1 plus the derivative of any constant is 0. Let's clean this up. This is a negative 1/2 x squared plus a 1x plus 1. That is our marginal cost function. Okay, once again, where I'm getting these fractions from, I'm just pulling out the powers and multiplying it by the fractions. Okay, now to figure out marginal cost of 4 units, this means we simply plug in 4 for x. So this will be a negative 1/2 times 4 squared plus 4 plus 1. This equals a negative 1/2 times 16 plus 4 plus 1. Let's see here. A negative 1/2 of 16 is a negative 8. So it's a negative 8 plus 4 plus 1. Add these up. What do we get? Negative 8 plus 4 is a negative 4. Negative 4 plus 1 is a negative 3. So the marginal cost of producing 4 units is going to be negative 3. So what does that mean? That means that let's look at it from 2 different perspectives. There's 2 different ways we can look at this. There's one way we can look at this. One interpretation says when producing 4 units, okay, because that's the x value we plugged in, right? Remember, x represents the number of units you're producing or selling. When producing 4 units, our costs are changing. So remember, a derivative is a rate of change. It's an instantaneous rate of change. So how are our costs changing? Well, because our derivative is a negative 3, our costs are changing at a rate of negative 3 dollars per unit, per additional unit. Produced. Okay? Or another way of saying, instead of saying that we're changing at a rate of negative 3, we can say that our costs are decreasing at a rate of negative $3 per additional unit produced. Maybe I like that better. Let's write that. Okay, when producing 4 units, our costs are decreasing, right? Because our derivative is negative, decreasing at a rate of $3 per additional unit. Okay, decreasing because our derivative was negative there. That's one way to look at it. Another analogous way is let's look at it in terms of units. So we're saying that if we produce an additional unit, our costs are going to go down by $3. Another way of saying that is if we produce not the 4th unit, but if we produce the next unit, in this case it's going to be the 5th unit. If we produce the 5th unit, costs will decrease by approximately $3. Okay? These are the exact same interpretation. I just want you to be comfortable both ways because your homework, they may ask you to select one interpretation over the other. Okay? So make sure you're cool with both of those. All right, so that's really what marginal cost is, and marginal revenue is very similar, okay? All right, so let me do some other examples for you here. All right, how about this example? This is a little weird one that I saw in the homework. Let's say we have the following cost function. Okay, and it's going to be a piecewise function. So let's say our costs will be 1,000 plus 50x minus x squared, and this is true for the number of units produced being between 0 and strictly less than 50. So in between 0 and 50 units, that's our cost function. If we produce more than 50 units, let's say our costs are going to be 0. Why is that? This is because of budgetary concerns. Maybe we can't produce more than 50 units, so after we get to 50 units, we're not producing anymore, so our costs will be 0. All right, let's do several parts here. Part A. I want us to find the marginal cost function here. So Find the marginal cost function. Okay. So we know we take the derivative, right? Excuse me. All right. So our marginal cost function will be, let's go over here. Since we started with the piecewise, we're going to have a piecewise as our marginal cost here. And let's go ahead and take the derivative of the top piece here. All right. So it's going to be the derivative of 1,000 is 0. Derivative of 50x is 50 minus 2x, right? That's the derivative of 1,000 plus 50x minus x squared. And this will be true for x's in between 0, strictly less than 50. Okay? And we know that, well, the derivative of 0 is still 0. Okay? So this is going to be the marginal cost when x is strictly greater than 50. So why didn't I put greater than or equal to there is because at x equals 50, this is where it gets a little weird. At x equals 50, it turns out that our derivative is going to be undefined. Okay? Why is that? Remember that a derivative is a limit. That's why we had to start with the limit. And for a limit to exist, therefore a derivative to exist, we need the limit from both sides, right, to be the same thing. Well, think about it. If I plug in 50 into this top part here, if I plug in 50 into that top part there, and if it does not equal 0, then that means that that limit won't exist at 50. And that's exactly what happens. Here, I'll prove it to you in the calculator. If I take 1,000 plus 50x minus x squared. Okay, if I go to my table here, if I type in 50 for my x value, notice we get a value of 1,000. So because of that, that's why at x equals 50, the derivative is undefined. So keep an eye out on that, folks, when you do your homework, okay? So this is the correct answer here, okay? So 50 minus 2x for x in between 0 and strictly less than 50. For any x is greater than 50, we're going to have a marginal cost of 0. But when x equals 50, our marginal cost is undefined because we don't have the limits agreeing from the left and the right. Okay? All right. Let's keep the same problem going here. What if we're asked to calculate marginal cost of 10 units? Okay. Well, when x is 10, that means we should be plugging it in to this part. Okay. Why is that? Because this is the formula that we use whenever x is in between 0 and 50, which 10 is. So our marginal cost of 10 will equal 50 minus 2 times 10, 50 minus 20, which is 30. And let's go ahead and interpret that. Okay. When producing 10 units, our costs are what? Increasing or decreasing? Our costs are increasing because our derivative is positive at a certain rate. And what's that rate? That rate is $30 per additional unit. Okay. Or we can say if we sell the 11th unit, we expect our cost to go up by approximately $30. Okay. All right, more stuff with this question, so I want you guys to be able to get to this homework efficiently. Part C. So what if you're asked to do this? You may see this on the homework. What if you're asked to find what's known as an average marginal cost of, let's say, what's our undefined value? 50? So because 50 is undefined, people still want to know what's my marginal cost at 50. Well, because it's undefined, we have to come up with a formula, and here's the formula that will be given to you. So it's 1/2 times, it's the limit as x approaches 50 from the right, times our marginal cost, plus, and this formula looks horrendous. but it's not that bad. All this means is you just simply take 1/2 of your marginal cost from the left and your marginal cost from the right. That's all that means. Okay? So, for us, the average marginal cost of 50 units will be, let's see here, we're going to take 1/2 times, well, the limit as we come from the right of c prime of x. Remember, that means values that are above 50. Well, for when x is greater than 50, our marginal cost is 0. Okay? So that's what the first part is. Plus the limit as x approaches 50 from the left of c prime of x. So then that's going to be the 50 minus 2x part. But we need to plug in 50 for x. So it's going to be 50 times, or excuse me, 50 minus 2 times 50. That makes sense. All right, so it's going to be 50 minus 2x there. I'm plugging in 50 for x because that's our x value that we're concerned with. All right, and then all that entire quantity needs to be multiplied by 1/2. So here we get 1/2 times 0, 50 minus 100. All right, y'all know the deal. 1/2 times a negative 50, and so we get a negative 25.